So we're not going to get into the inner workings of Unix, just the command line, the basic Unix commands that you can use to manipulate files. So to start off, let's see how we can manipulate file using the graphics user interface, what you think of what the operating system is. In fact, what the operating system is a bunch of code that make everything work. The part that a human user gets to interact with, this part that we can drag around, manipulate folders. This is really just the graphics user interface part. Without this part, the computer still works. And if you have an automated system that, let's say, drives a spaceship to Mars, the underlying operating system is all you need to get the job done. If no person is interacting with the computer, on the onboard computer, let's say it's an unmanned mission, then you don't even need the graphics user interface part. It's extra code. So we all know what a file is, I hope. When you're using, I'm going to use, throughout this video, I'm going to use Mac OS as an example. It's pretty much the same case with any other operating system. But here is a Finder. You have in this window here a bunch of icons, each one representing a file. A file is a storage, is a collection of bits. In today's computer, in the future we may have other representation system, but for now everything is binary, so they're bit based, and a file is a collection of bits. Depending on what that file does, the bits mean different things. It may mean text, it may mean an image, it may tell the computer to do something, which is a program. Okay, so that's a file. And oftentimes we have a lot of files, so we want to organize them, and you are familiar with the concept of a folder. So all of these are graphics user interface version of the icons and the thing of a folder, which when you click in, you see all the files inside. Is really just a different representation of the files and directories that the underlying system does. So if we go back to this, I have this, and if you look, this is the path. It's on my notebook. It has a hard disk. Under that hard disk, there is a folder called user. Under that, there is my own, and I use Dropbox and da. This is how it goes all the way to the current folder, and it's called code. Here on the command line, and I have the same thing. I can show my current working directory. A directory is basically, not completely the same, but basically the non-graphics user interface notion of a folder. In fact, you can call it a folder as well. So to print my working directory, the Unix command is print working directory, pwd. And you see, this is how we get to this current directory. It's a directory called user under the root, which starts from a slash, my directory, Dropbox, and so on and so forth. And if I want to list the content of the directory to see what's inside, I say list. And you see this, a lot of people don't want to type back in the days, so they define these names to be a shortened version of the name that they suggest. And I see these, and if I put them sort of side by side, you can see, well, it's really the same in different format, right? I have examples over here. I have code for different lectures, and I can go in them. Same thing over here. If I want to change the directory, say, let's see what's inside examples. Again, on the user interface, on the graphics user interface, I click and I go in the command line. That becomes change directory. If I want to change the directory into examples, and I have this. So this is the same thing as currently what the directory is versus what's shown here, right? It's the same idea. Okay, I have what is the 7 files, and if I do a list, I will see 7 files in much less fancy way, just a textual representation. But if you compare, oh god, but if you compare, they have the same content. Okay, so change directory. Now, you can be fancier than just list. You can say list in long form. That's what -l means. It's an option to tell ls, the command, I want to show more. Now you can see the read-write permission over here. When the file was last edited, it was July 17th. At what time, and so on and so forth. For instance, if I edit this file, let's just look at this and you will see this is dwarf.py. Let's say we edit it. My favorite editor is Vim, so I'm going to edit that file. And let's say I'm not doing anything particularly interesting, but I'm still writing it back. Now, if we go back and do an ls again, we will see that the dwarf's last modification time changed to the current time. Okay, so which is different from before. And you can have fancier options. You don't have to know this, but let's say what I tend to use a lot is to list the files in reverse timing order, and that's tr time, sort them based on time, but in reverse order. So the most recently modified file came into the bottom. Now, these are the things that you can, of course, do in a Finder by clicking these different viewing options. But there are a lot more that you can do than what the graphics user interface or the GUI allows you to do. Okay, but how do you know? How do you remember them? Do you have to remember? And the answer is no. And in the past, the Unix system will give you all these manuals. Today, you can read them online, Google them, see what the options are. But in the past, what we were told is the manual, which is man. You want to see how ls works, you man ls, and that tells you what goes on. List directory content, that's what it is. In a nutshell, you can say ls with a whole bunch of different options, and you may or may not give them these options. That's why they're in square brackets. That means optional. You may or may not give a file name. So for instance, if I want to only list the file that start with A, so I have A and nothing. I don't care about what happens after that. And there are ways to express that. Star means it matches any string to the name. So then I only see that. And if I want to see anything that ends with py.py, I can say star py. And I see all of that. These are things not very easily, that cannot be very easily done on a graphics user interface. So this is commonly true. There are a lot more you can do in the underlying interface than a higher interface. The higher interface usually picks the common things that you do, make it intuitive, but the underlying command, or even when you go down, accessing the interface to the operating system directly with system calls and such, it will be even more powerful and faster. Okay. So let's say there is a file. Usually when you use an editor, they create some sort of backup file with some weird character in it to indicate that this is not a regular file. Suppose I don't want them. I want to get rid of them. Okay, and that is remove. Again, you can see you get the theme that here that these command names are really just shortened form of the word that describes what it does. Let's say I want to delete this file. So I do that and it's gone. You might have seen it. This is already deleted from here. Okay, so because it's the same underlying reality. Let me try to do this. Let's delete something else. And you will see, keep an eye on here, and you will see that that graphics user interface gets updated very quickly when I remove the file. See, that's gone, right? Of course, here what do? You use right click, you find delete. I guess here it would be move to trash, right? So this is an additional thing because people sometimes delete things by mistake. RM cannot be undone by itself. You have to wrap the command with something else to get that done. So we'll not get into that. Okay, so what if I want to do a copy? If I want to copy a file, let's say here, what you will do, use the graphics user interface is perhaps to duplicate it and then start to change it. You know, for instance, rename it into b.text. Okay, so the same kind of thing can be done perhaps more directly by saying copy. So if I want this file into something else, c.txt, I copy, and I can see this is a file catalog to show what the file is very quickly on the screen. Oh god, this is a very big file. I don't know why it's... Okay, let's try something else. Cat a.c. Right? It's our print hello world program. So let's copy that. Maybe. Copy a.c into b.c, and you can see we have another file over here, right? And you can show that it has the exact same content as before. So that's copy. And you can copy files around, copy it from one directory to another directory. So for instance, I want to copy this into the directory above the current directory. And that is shown, if I show this to you, you will see that there are two special directories, two special files, if you wish, in a directory. One is called dot, and the other is dot dot. Okay, the dot dot means the parent directory. Okay, I am in a directory. If I want to go somewhere else to the parent directory, I go. So again, the current directory is example. If I go into dot dot, guess what directory will we be in? It's the code directory. Okay. So in Finders, for those of you who use Mac, and if you have a little thing over here, you can go to your parent directory, like so. Okay. So then you can copy things from one directory to another. So for instance, if we look, we don't have the a.c here. Okay, you can see it's not here. There's no file called a.c. But I can copy the code called a.c in my example directory into the current directory. Okay, and I will have it. It's right there. Okay. So you see, these are commands that really correspond to your file manipulation, the common things that you do. I think I'm just gonna tell you a couple of these without going into too much detail. But the point here is, so why don't we use the graphics user interface? I'm not against GUI. They're good. They're very useful. But what happens is this. This user interface is really for end user. Okay, a guy who uses the computer to do whatever he does, not the design of a computer, not the creation of more computational tools. And you might be different. You might be using these to program them, to tell them to do useful things, to present the final product as an app to final users. So you are the power users. And you will soon realize that the lower interface starts to be more and more powerful, even though it's harder to remember at the beginning. And this is just like programming the computer. You can concatenate commands together. You can put all these commands into another file and execute that file, which tells you to do a whole bunch of things together repeatedly. For instance, I write papers in my research life. Every time I write a paper, what I do is I create a directory, copy the basic files into those directory, the starting files, the template, the skeleton, I would give the file the correct permission so that me and my grad students can read and write them together in a common folder. So all of this I do again and again and again every time I start a paper. Of course, I can do this with GUI. I can create a directory by saying new folder, give it a name, go find those files somewhere, and then put them in. So this requires me going around, dragging things, double clicking, a lot of action. It's very tedious. Okay, but on the other hand, if I do this with my script, I'll just show you where I have it, and that's a script that I created called start paper. Okay, it's a whole bunch of commands, and in fact, inside those commands, there are slightly more complicated system. You can already see some of the things that are quite understandable already. I have copy command, copy a file, a whole bunch of files from some directory to the current directory. I have those, but I also have slightly complicated things called if statements. Okay, we'll see them when we're programming, and that makes sense because this script, this short section of program can actually do things slightly more intelligently. It depends on what happens. If this happens, then do that. Otherwise, do something else. Okay, and this is a lot faster when I want to start a paper. This is just, of course, my example. And if you are dealing with computers a lot, and you will start to see how commands are really just another way. These terminal commands are really just another way of programming the machine. In fact, I believe Apple has provided a tool. I tried to use it. It wasn't very easy to use, but it's an automator. Okay, has a little robot holding something as an icon. You can record actions, and that's really just for the uninitiated. You can get most of that done using this simple command line commands. So again, this is not something that you absolutely have to use, but you will see that if we limit our vocabulary to interact with the computer, they are very strictly followed, and that's in a sense what programming is all about. We're gonna do this. We're gonna focus mostly on using Python and then write statements and then see what the program can do for us. But what I want you to see is that really programming is various degrees, and even when you're interacting with your personal computer, moving files around, preparing for submission for your homework and whatnot, they're really another way of programming the machine. And if you try to force yourself to do that, I know it's perhaps unfamiliar to some of you, you will get used to the idea of talking to computers, and you will see the quirks, you will see the frustration, but you can overcome them and see that's why we're calling these programming languages. We're really trying to talk to the computer, to tell it what we want it to do. They're kind of not very accommodating, not very error tolerant at the moment, and part of that is just efficiency. Okay, part of that is we're not that good at tolerating, at being robust, of handling human fallacies just yet. Okay, so now we're going to go back to programming in the Python.